gravity, for example, is pulling you down towards Earth at a limited speed of 9.8 meters per second squared. However, many people do not think so. Let's see what they have to say. Our first question is, why do astronauts float in space?
Because there's no gravity.
So why do astronauts float in space?
Isn't there no gravity in space?
Why do astronauts float in space?
Because it's got no gravity?
So, why do astronauts float in space?
Because there's no gravity?
So why do astronauts float in space?
Because there's no gravity.
So our first question is, why do you think astronauts float in space?
Because there is no gravity.
If you have the diagram here with the astronaut, what would the astronaut do in space? Would he just kind of like float there, or what would he do?
I have no idea.
Okay, so if you see this diagram here,
Yes.
what do you think that the astronaut will do?
Well, the closer he gets to the planet, the more he'll be pulled to it
That's it.
by gravity.
So going off of that, then when do you think the force of gravity kicks in then, if there's no gravity in space?
I believe when he enters the atmosphere of the planet.
Okay.
Okay, so
I'm going to fall in his belly.
There is gravity in space, and so the astronaut is floating because he is constantly in free fall. So the force of gravity is pulling him down,
But I thought there was no down in space.
pulling him towards the planet.
Oh.
so actually there is gravity in space, and you're actually in a constant state of free fall. So have you ever been on the Tower of Terror in
Yes,
Disneyland?
I know what you're talking about.
So like right when you start falling down, you feel like you're weightless, like you're almost in space, and that's but you're like strapped in a seat, so you
Right.
don't fly away. But that's what's happening in space is you're falling, like hurtling towards the Earth, but you're also in orbit around it. So you're falling towards the Earth just as fast as you're rotating around the Earth. So you constantly make an orbit, and that's how you seem like you're weightless, but you're actually moving really fast. So actually, there is gravity in space, and you're falling towards the Earth because they have like a gravitational attraction towards each other because they both have a mass. But you're falling towards the Earth at the same rate that you're rotating around the Earth, which is why we have orbits. So because you're rotating fast around the planet as fast as you're falling towards it, so you never actually hit the planet. You're just in an orbit.
But okay, so if you were falling towards the planet,
Yes.
but you're also in orbit, wouldn't you still fall actually towards the planet and
Yes,
get
but
back?
you're the planet, and then you're like falling down, but you're also going like.
Oh, you're also going out.
around. Yeah.
Okay.
So you're going around it.
Alright.
Which
That
is how you
makes
get orbits.
slightly more sense.
Let's first take a look at the equation for gravitational attraction. No matter where you are, the equation is written as F equals gmm over r squared. This equation relates the mass of any two objects with the radius between them. Because r is in the denominator, the further away you are from the object, the weaker the gravitational attraction.
Here's an example. The Swagstronaut and the Planet of Success are pulled towards each other proportional to their masses and the distance between them. The force of gravity pulls the Swagstronaut towards the planet and the planet towards the Swagstronaut. So why doesn't he crash into the planet? Well, he's actually moving in an elliptical orbit around the planet because his acceleration is tangential. As a result, it causes him to orbit the planet instead of crash into it. This creates an overall circular rotation.
The Swagstronaut's falling velocity is equal to his rotational velocity, which causes him to move in an orbit. So he is actually falling towards the planet. But because his net force is in a circular rotation around the planet, he never actually crashes.
Where else might you experience the same weightlessness as felt in space? Swings.
Bloody hell! It's Harry Potter! Yay!
This force of gravity does not just apply to outer space. It can also relate to many everyday things, like swings. At the bottom of the swing, the girl has tangential velocity, but the chains keep her moving in a circular motion.
At the top, her velocity is not fast enough to accelerate her in a full circle, so she falls back downwards. When this happens, you can see her body lift off the swing and fall in free fall back to the ground. This demonstrates the effects of gravity, whether on or off the earth.
What's another example where you feel the same weightlessness as in space?
The loop-de-loops of roller coasters.
Another place where you experience weightlessness is at the top of the roller coaster. The velocity at the bottom of the roller coaster is carried throughout the loop, but must have enough speed to carry the cart through the loop. Looking at the forces, like normal force and gravity, the smallest amount of velocity to carry the cart in a full circle is given by the equation the square root of g times r. The mass of the cart does not matter in this equation due to the centripetal forces.
Looking at the top, the net force acting on the cart is the mass due to gravity and the normal force. Your weight is pulling you down, but the centripetal acceleration is providing enough force to keep you moving through the loop. If the velocity of the cart is at the right speed, then at the very top of the loop, the rider should float due to the forces canceling each other out.
Now I know.